Our final speaker for today, and it's really an opportunity and a pleasure for me to introduce our co-director, Martina Stenzel, who will be closing off today's proceedings. So Martina, a brief introduction, and I'll paraphrase this from Aaron's notes. So Director of this training centre's UNSW node, ARC Laureate Fellow of the Australian Academy of Science, and legend. So, so over to you, Martina.
Who wrote the legend part?
Yeah,
Can you guys hear me?
Yep.
Can you hear me?
Yep.
Go ahead.
Yes. Okay. So I would actually like to share my screen. Okay, how do I share my screen? I'm not sure why I can't share my screen at the moment. You did allow me to share my screen, didn't you? Do you see anything?
We'll just see a, oh, now there you go, it's uploading now. If you put it into presenter mode.
Yep. There you go.
Great.
Oh, good. Fantastic. So I actually don't want to go too much into depth, but I just sort of want to share a little bit my experience with industry as an academic. So we heard now really great stories from the students. We heard people who are sort of a little bit with Kathy on the interface almost between academia and industry. And of course, Richard shared all the gossip and the insight from companies, which I think was great. There was some really, really good advice. So when, as an academic, I have to admit, I've never left university. I've never left the school system in my whole life. So I have no idea how industry works. And for a very long time, I had a very naive view about how things are working. And so I thought, well, I'm going to develop something in my lab. It's going to be absolutely brilliant. I write papers or patents first, and then maybe papers. And I'm going to find a great industry partner who is interested in that. The reality is very, very different, as we all heard. But what I want to share today is a little story that things can actually work the other way as well. That you start off with something, try to solve a problem with industry. At first, you might not be the most excited one, but then you start getting into it. And you think, although this sounds like such a simple problem, you can actually get a lot out of it for you personally, or for me as an academic. First of all, you need to find a solution. It should be a solution that's cheap, that's quick. You can get approval for it very quickly. But while you're doing that, sometimes you can, as an academic, you have the opportunity to ask the hard question. Why is that? Why do we get these outcomes? As Richard said in the beginning, if you, for example, move a lever and it gives you a great product, you're not asking why, but I can ask why, and I actually can take this idea and open up new research opportunity. And that's something we've done with the last ITDC I was part of. I was part of as a just regular researcher in the Training Center for Advanced Technologies in Food Manufacture. So the program, the project I was involved with was really solving this the plastic waste problem. So we were talking with people from Coles and Woolworths about their issue with having all this food packaging for meat, for fruit, and so on, which of course is used once and then it contributes to the plastic mountain. So the question is, what can we use that is a replacement? Of course, we can always find replacements, but in the end, replacements can be just as expensive to produce. So you can always make, let's say, a degradable polymer, but to make degradable polymers, you spend a lot of energy. So the best thing is really to look into waste products from the food industry. And Australia has actually a lot of waste products, and one of them is banana. So after you harvest the plant, the banana plant is left over, and at the moment it's been chopped down and left on the field. So it sort of fertilizes the field again. But of course, there's some great products in this banana stem, in the banana plant. And one is actually here in the stem. This is when you take the banana plant, you take the stem and you chop it into small pieces. And this banana stem consists predominantly of cellulose. And not just any cellulose, it contains actually cellulose in a way that it provides a lot of mechanical stability to the plant. And so when we look a little bit closer here, we find here the blue parts here. This is your cellulose microfibril. That cellulose microfibril actually consists of a lot of nanofibrils, and they're called nanocellulose. So this is now a great material because we can isolate this so-called nanocellulose very quickly, and you get now these little fibers. And so these fibers here can now be processed into paper. And it's actually not like your normal paper, not like your the paper you would have for newspaper, or the paper you can maybe put your apple in there. It's a piece of paper that has a much higher stability. It feels much different. It feels almost more like baking paper. However, that material, as great as it was already, it was still a little bit brittle. And so when we talked then to the industry partners, what they really want, they want something that is of course flexible, because you want to wrap it maybe around your meat tray, but you also want to have something that's clear because the customer wants to see what's inside. Then you might want to have different oxygen permeability. Sometimes you want oxygen to go through, other times you don't want, but you also want things to be water repellent. And so now just think of a piece of paper. Of course, none of them actually meets these demands, but our nanocellulose does, in a moment where we start blending it with other things. So we started blending the nanocellulose, for example, with clay, with some synthetic polymers, and suddenly you get these materials that are see-through, that are water repellent, that have actually very high mechanical stability. And we also tried other materials, other waste products, for example, from the cotton industry, and it actually gives you a more see-through material, a clearer material. It has less mechanical stability though. So really, all these waste plants, but just by blending things, by processing things, you can now get very nice films for all purposes, really. So I nevertheless looked at these fibers, and I thought, well, they're really, really interesting. I mean, there's so much you can do. But I personally work a lot in the field of nanomedicine. And just to give you a very brief overview what nanomedicine is. And so nanomedicine actually tries to address the problem that whenever you inject a drug into your body, the drug goes everywhere. So you might have a tumor sitting here at your hip, but once you administer the drug is distributed all over the body, and that causes these side effects. So whenever you undergo cancer treatment, you might lose hair, you might have kidney problems, and so on. And actually only 1% of the drug that gets administered ends up in the tumor. 99% is secreted again, or is accumulating in your body. So nanomedicine is a way of solving quite a lot of problems. And I don't really want to go in detail, but what you do is you take nanoparticles, you load these nanoparticles with drugs, and as a result, you get a better accumulation in the tumor. But it also has a lot of other advantages. For example, you can now protect your drug, for example. So most nanomedicine, they're round particles. But there's a lot of reason why we want to use elongated particles. And one reason is these elongated particles, they actually circulate much longer in the bloodstream. So, but it's really quite hard to get elongated particles. And so when I looked at this nanocellulose, I thought, that's fantastic. I showed now how I can isolate nanocellulose from a banana plant almost by the kilo. I could now easily use the nanocellulose to make drug carriers. And that's basically what we've done. So we took the nanocellulose, not from a tree, but from a banana plant. You need to modify it because nanocellulose itself still has this tendency of aggregating. So we put some polymers on the surface. We load it here with drugs, and then you can basically inject it into your into the body. Well, that's the long-term idea. And so that actually works really quite well. So we've done that here. We used nanocellulose, and the idea was that we have a really good uptake here by the cancerous cell line, but very little uptake by a healthy cell line. And so the way of showing that is that you follow the pathway of the nanocellulose into the cancer cells. So what you're seeing here are cancer cells with the optical microscope, the fluorescence microscope. And the green stuff here is now our nanocellulose inside the cancer cells. So it actually goes into the cancer cells, releases the drugs, and it leads to cell death. So this is just basically to show you that it really works in both hands. I think really just what we need to do is we need to have a sort of an open mind about things. And problems in industry can well be very much academic problems. They can be very, very exciting problems. And I really liked today the variety of talks. It really shows that the relationship between industry and academia is not fixed. It's very different. It depends on the project. It depends on the people who are working on it. It depends on the challenge. And so I very, very much enjoyed all the different talks. So we heard talks today about how to better test the materials, about how to have paints without footprints. We want to make reactions more efficient, but maybe we also want to chase bacteria. So the problems in industry are very, very wide. So the variety of problems, and we also heard from our industry partner what sort of challenges they face and how they would like to tackle the problems. So, I mean, Richard made it sound in the end, well, really all we want is something that's faster, better, cheaper. But when I heard these talks today, I really heard a lot about understanding things as well. So I think there is somehow an awareness that if we somehow understand things, although if it might not be down to the molecular level, we can actually make bigger things. And so I would like to conclude with this very, very simple slide where we have an overlap between industry and academia. And of course, you see this overlap in the center, but very important are these arrows that go in both directions. And I personally learn a lot from my experience with industry, because there are new challenges, because this faster, better, cheaper it's not so easy as it sounds. And I think you all learned that now. It's not that easy to say, well, I want to increase my productivity by 10%. That actually is, in some ways, an academic challenge as well. So I think in the end, working on the interface between academia and industry, it's not really just alone the science we have to learn, but we have to bring in a lot of new skills. We have to be able to adjust to the situation. We heard that we have to have many different hats on. You might have to be thrown in a topic where you don't have any prior experience, and you have to work your way through it. And that requires new skills. You have to sort of listen to people. You have to maybe formulate your problem to other people in a way to really get this conversation going. So yeah, and I would like to wrap up with my little perspective from industry. And from my point of view, I really would like to thank all the speakers today, because I think that was really great seeing all these different angles. And I hope that our industry partner and the students really got a lot out of it.
Brilliant. Okay, thanks very much, Martina.